right, so in this lesson, now that we have talked about how to write chemical reactions and how to balance them, we're going to talk about the 5 different types of chemical reactions that you might see. Okay? So there are a total of 5. The first one is synthesis. So I'm going to show you just the generic breakup of them and go through all 5 of them, and then we're going to go back and practice with them. So for synthesis reactions, notice you take 2 different reactants, so A and B, they're separate, and they combine together to form one single product. So that is a synthesis reaction. You are synthesizing something, you are making something. Decomposition is the exact opposite. You have one compound that's together, A and B, and it breaks apart into its individual parts, A plus B. Okay? For a single replacement reaction, notice you have one element, element A, and it's going to go in and it's going to kick out an element. It could be A or it could be B, and we'll talk about that when we get to single replacement reactions. But it's going to kick out one of the original atoms, and it's going to form a new compound with the other element, and now the element that was originally in the compound is by itself. So if you can think about it, if you want to think about it like you've got someone all by themselves and you've got a dance partner here, it's that person going in and kicking out and stealing someone's partner, basically. That is a single replacement reaction. A double replacement reaction is similar to that, except it's kind of a do-si-do. So notice A and B are partners, C and D are partners, and then they switch up partners. So A goes with D and C goes with B. So unlike single replacement where you have just one element going in and kicking out, in double replacement you have a complete switcheroo of partners. Okay? And then finally, for combustion, in combustion reactions, you have what we call a hydrocarbon. And just as the name implies, a hydrocarbon has hydrogen and it has carbon in it. And it reacts with oxygen to form, always, carbon dioxide and water. Okay? You will always have carbon dioxide in water forms. Okay? The other thing that is produced, which we normally don't write in the reaction, is energy. So combustion reactions, whenever you see an explosion or a fire, that is a combustion reaction. When I light my stove in the morning, or in the afternoon or evening, or whenever I light my stove, that's because the gas that's provided is my hydrocarbon. It is reacting with oxygen that is in the air, and it produces carbon dioxide and water. Okay, so if you ever see just carbon dioxide and water as your products, and a hydrocarbon and oxygen as your reactants, then you have a combustion reaction. Okay? So let's look at a couple of examples here. For this synthesis reaction, remember 2 separate elements combining together to form one single one. So let's see. So sodium reacts with oxygen. All right, so sodium Na is going to react with oxygen. Okay. Well, if they're combining together, sodium is a metal, oxygen is a nonmetal, all I have to do is cross my charges, and I know what it forms. Well, this would give me Na2O. I'm going to really quickly balance. I've got 2 oxygens on my reactant side, 1 on my product side, so I know this has to be a 2 in front. Then 2 times 2 gives me 4, so I need a 4 in front of sodium. So that is a synthesis reaction. Take 2 separate components, combine them together, and you've got your one product. Okay, let's look at a decomposition reaction. Remember, you've got one compound, so in this example, HCl, and it's going to break up into its component elements. Well, you've got hydrogen and you've got chlorine. The one thing you need to be careful about here, normally this would be perfectly fine to write, except hydrogen and chlorine are both diatomic elements. So instead of writing H and Cl, I'm going to write H2 and Cl2. Okay, and now I just need to balance. So I'm going to put a 2 in front to balance. So that's a decomposition reaction. I broke apart one compound. Let's look at a single replacement reaction. All right, magnesium reacts with sodium nitrate. So remember, sodium has a +1 charge. Nitrate has a 1- charge. Okay, so when I cross charges, that becomes NaNO3. Now, I don't expect you to know this at the moment. We will work on this in the next section. But what happens here is magnesium is going to go in and it is going to kick sodium out. And so what you end up getting is magnesium now forming a new compound with nitrate. So magnesium now forms a new compound with nitrate. So I've got to figure out what that compound would be. So that will be MgNO3 because I crossed my charges. And then sodium got kicked out, so it's going to be all by itself. And remember, sodium can be by itself because it is not diatomic. Okay? Now I need to go and I need to balance this reaction. So I've got one magnesium on my reactant side, one on my product side, one sodium. I have one nitrate on my reactant side, but two on my product side. So I'm going to have to put a 2 in front of sodium nitrate and then a 2 in front of sodium. And I am balanced. So again, I don't expect you to be able to do that quite yet, but I do expect you to be able to recognize that magnesium, by magnesium going in and kicking sodium out, that makes this a single replacement reaction. All right, double replacement reactions. We've got two partners. So I've got potassium with oxygen and lead with nitrate. So let's write out their formulas. So potassium and oxygen, when you cross your charges, that'll give you K2O. And then lead 4, so it has a 4 plus charge. And remember, nitrate has a 1 minus charge. So when I write this formula, I get Pb and then NO3, 4, because I crossed my charges and I made sure my nitrate was in parentheses. So notice here, now A and D will form a compound, and C and B will form a compound. Okay? And again, we're going to get into this in grueling detail in an entire, we'll actually spend a couple of lessons on double replacement reactions, but following this up above, what I know is that potassium will now form a compound with nitrate. So I've got to cross charges, and so that tells me I have KNO3. And then lead is going to form a compound with oxygen. So lead is 4 plus, oxygen is 2 minus. So when I cross my charges, I get Pb2O4. Keep in mind I need to simplify this. So it's going to be just PbO2. Okay? So again, I don't expect you to be able to actually write out your products yet, but I do expect you to look at this and say, oh look, potassium's with oxygen, but now potassium's with nitrate. And lead was with nitrate, but now it's with oxygen. So this must be a double replacement reaction. Okay? Now I'm going to quickly balance. I've got 2 potassiums on my reactant side, only 1 on my product side, so I'm going to put a 2 here. I've got 4 nitrates on my reactant side and only 2 nitrates on my product side. So what that tells me is I was incorrect. This shouldn't be a 2. This should actually be a 4. Okay, so now I have 4 nitrates and 4 nitrates, 4 potassiums on my product side, so I need to put a 2 here. So I have 4 potassiums, and I've got 2 oxygens on my reactant side, 2 oxygens on my product side, 1 lead, and I am balanced. So let's work on actually just classifying these. So I'm going to simplify this. I'm going to put synthesis. This is going to be decomposition. This is going to be single replacement, double replacement, just to have a shorthand, and then combustion. All right. So notice, for example, 1, I've got hydrogen and bromine reacting together to form one compound. So this is going to be a synthesis reaction. Okay. For the next one, notice silver, nitrate, and sodium chloride react to form. Well, notice silver now becomes a new compound with chlorine, and sodium becomes a new compound with nitrate. So I have a do-si-do of partners. So this is going to be a double replacement reaction. For example 3, notice I've got 1 molecule and it is breaking up into 2 individual parts. So as soon as you have 1 molecule breaking up into 2, that's going to be a decomposition reaction. For example 4, I've got 1 element going in, and notice what zinc does is it goes in and it kicks copper out. And we can see that by looking at our products. Copper is all by itself and zinc is now with chlorine. So I know that that is a single replacement reaction because 1 element went in and kicked out another element to form a new compound. And for the final reaction, I've got a lovely hydrocarbon here. It's reacting with oxygen to form carbon dioxide and water. And so remember, if you have a hydrocarbon reacting with oxygen and your product is only carbon dioxide and water, I know that this is going to be a combustion reaction.